today we're talking empirical probability. Our objective for today is to understand empirical probability. Most of you know it as experimental probability, okay? And we're going to kind of lead ourselves into being able to eventually use that probability to evaluate the outcomes of decisions. Now I say eventually because that is after spring break, okay? So that'll go with that whole unit we've got when we come back from break. We are talking empirical probability, which is an estimate that an event will happen based on how often the event occurs after collecting data or running an experiment. That's where the whole experiment comes from, okay? It's based specifically on direct observations or experiences. And by the way, you're so welcome for that. All right, let's get going. When we're looking at this, for us, most of this is going to happen on tables or with data from tables. When we get back from break, we'll probably do some experiments ourselves to use our probability to maybe kind of, make guesses on what kind of life insurance or car insurance we should use or what kind of a meal plan we should use when we go to college. But for right now, we're just going to deal with data from tables. Okay? The table shows students by gender and type of school in 2005. You pick a student at random, find each probability. Now, we've got to remember that probability for us, for experimental probability, is the number of times something occurs over the total number of times that event happened, or when we're looking for specific events over all of the events. Okay? Now, before I'm even going to start, I really want to actually total up some things in my table, because I know that probability is out of totals. It would be very, very helpful if I knew what the actual totals were. Okay? Because I have everything broken down by two-year colleges, males, females, and everything like that. If I look at this and I add these two, then I will get 4,328. And I'm going to end up needing that number. Okay? Same thing goes for this 9841. Same thing goes for this 3303. And I know it's a little bit kind of, wonky, not really kind of fitting, but at least it'll fit on your paper. And then, of course, I'm actually going to total up this as well. I've got 7,539 when I add these three numbers straight down. Okay. And then I also have 9983 when I add my second column. And what I can do is I can add the last row in red, the last column in red, or that last row in blue, and what I can get is my actual total. Okay? And when I get that total, I'll have a total of 17,472 students. Okay? So that total is 17,472 students. Right? And I'm going to need those numbers when I go to do this. Now, part A says I want the probability of female given that it's a graduate student. Now, that's what this little thing right here means. That means given, which basically means that I'm only going to pull out of whatever's coming after that. So I'm only going to pull from graduate students or graduate school. Okay? So then I just look at my numbers, and really what I want is I want the number of females over the total number of grad students. Okay? That's what this is, females, okay, over grad students. All right, so the probability that it is female given grad school. All right, so I go and I'm actually looking at this number right here, 1954. Okay, because A, that's female right there. And then it's also grad schools. So basically, you're kind of looking for the intersection of those two cells. That's that column and that row, they intersect right here. So I'm going to need 1954 over, and my total number of grad students is 3303, right? If I'm looking at this, I'm going across, right? I'm looking at that and I'm going across. I'm going to clear my table up a little bit. So I need that over 3303. All right. So when I do that, of course, I'm going to write it as a fraction and as a percent. Okay, so there's my fraction, there's my decimal, 0.592, and so my percentage is 59.2%. All right, and I'm going to do basically the same thing for these other ones. Probability of female, so I'm now on P right here, probability of female. Well, this is pretty straightforward. Okay, this is pretty straightforward. You are just going to add up all of your females right there. Okay. So we get 9,983 females over, well, we need our total number of students. That's 17,472 students. And that is, of course, 0.568. Okay. So 0.568. And of course, as a percentage, 56.8%. I guess I kind of glossed over that, but we got to remember that we can write probability as a fraction, anywhere from 0 to 1. We can write it as a decimal, or we can write it as a percentage. All three of them. Okay, and so in everything that I do today, it's going to be all three so you can see them. All right, so now we're going to take a look at probability that it is a 4-year student, given that it is a male. Okay, we want to look at probability that it is a 4-year student, given that it is a male. Well, all right, so basically what we're going to do is we've got 4-year colleges right here. We've got males in thousands there. These two are going to intersect right here. So that's actually our number on the top. That is what we're looking for. So we got 4324. And then, of course, it's going to be out of the total number of males. Remember, we want to stick with just the males, not the entire population, just the males. Okay? So basically, it's almost like this is your numerator, this is your denominator, kind of, so you can kind of look at it that way. And then, of course, when we get that 4324 over 7539, it's about equal to a 0.574, which is a 57.4%. Okay? So there's our 3 examples for probability as far as that first table is concerned. And then this is called kind of conditional empirical probability. All right, so we're heading on to the next example. Okay. A utility company asked 50 of its customers whether they pay their bills online or by mail. Okay. What is the probability that a customer pays the bill online given that the customer is male? Okay. So if we want to look at this and we want to see how it's written, kind of how we wrote the first problem, it's going to be probability online given that it's male. I'm going to do the same thing. I want to add up my columns and my rows so I know what's going on. I can see that this is going to be 20 right here. 12 plus 8 gives me 20. 24 plus 6 is going to give me a 30. All right, I'm going to add my columns now. I'm adding straight down my columns. I get a 36 here and a 14 there. When I add that last row and that last column, I should get the same number. That same number, 50, which totally matches the number of customers that we were looking at. So then I want to know probability of online, given that the customer is male. Okay, well then I'm going to go and I'm going to find my online column. Okay. And I know that this is 12. I know that 12 males are paying online, so I know it's going to be a 12 over, and then again, we are only looking at the male customers, just the male customers, so this is going to be over a 20. Not over the 50. We're not including those females. And then, of course, that is going to reduce, and we want to reduce that fraction to a 3/5. And, of course, as a decimal, it is a 0.60, and then as a percentage, it is a 60%. Okay? So, again, 3 different ways to write it. As a fraction, as a decimal, and as a percentage. All right, guys, last one. So we want the researchers asking shampoo users whether they apply shampoo directly to the head or indirectly using a hand. What is the probability that a respondent applies shampoo directly to the head, given that the respondent is female? Okay. So again, we look at what we want. We want probability, okay, directly to the head, given that it is a female. Okay. So we want probability that is direct, given that it's a female. So that's what we're looking for. And again, adding up my rows and my columns. 2 and an 18 gives me a 20. 6 and a 24 gives me a 30. That means they asked 20 males and 30 females. Okay, and out of those, 2 plus 6, 8 of them said they put it directly onto their head, the shampoo. And then, oh gosh, 42 of them. You know I can't do math in my head. 18 plus 24 should give me 42. All right, so 42 of them it goes into the hand first and then onto the head. And again, I'm looking directly on the head, given that it's female. So I find directly onto the head, this one right here. There are 6 females that do that. So we are going to do 6 over, we've got a total of 30 females that we've asked. And of course, this reduces to 1/5, which gives us 0.2. And so our probability is 20%. Okay, our probability is 20%.